Hello viewers, I am Kausalya. Today we are going to see problem number 12 under the category Routh stability criteria. The problem is a feedback system has open loop transfer function which is given by this expression. Determine the maximum value of k for stability of a closed loop system. Here the open loop transfer function of a system is given and we are asked to find the value of k for which the system will be stable. So whenever open loop transfer function is given, our first step is to find the closed loop transfer function. So here g of s is given by this expression. This e to the power minus s can be replaced by 1 minus s, right? So after replacing, we are going to find the closed loop transfer function. So what is the formula for closed loop transfer function? It is given by C of s by R of s is equal to G of s divided by 1 plus G of s into H of s. So this is our G of s value. Just substitute the value of G of s in this equation. So here when you substitute, we are getting an expression G of s divided by 1 plus G of s and the value of H of s is 1. Right. So the next step is we have to take LCM. So the numerator part remains here as such, and when you take denominator, you see you have to multiply this term with 1 here. So s into s square plus 5s plus 9 plus this k into 1 minus s and the entire part divided by this denominator term s into s square plus 5s plus 9. Since both the denominator terms are same, they cancel each other, and finally we are having an expression as k into 1 minus s divided by s into s square plus 5s plus 9 plus k into 1 minus s. So this is our closed loop transfer function. The denominator part of the closed loop transfer function is known as characteristic equation. So we have to take this characteristic equation and we have to analyze whether the system is stable or not. So this is our characteristic equation. We are simplifying this characteristic equation. First step is I am multiplying. You see s into s square, s cube. S into 5s, 5s square. S into 9 becomes 9s. Right. Next k into 1, k into s, ks. Right. So as we are having minus, so plus into minus becomes minus ks here. The next step is I am again simplifying, taking the common terms. So s cube plus 5s square as such, and here I am having two s terms, 9s and minus ks. So both these terms have s, so I am taking s commonly outside. So the remaining terms will be 9 minus k, right? Plus the remaining term is k, so plus k equal to 0. The next step is we are going to form Routh array. So here the maximum power of s is 3, that is odd number. So we have to join all the odd powers. So here s cube and here it is s to the power 1. Right. So the first element is s cube. The coefficient of s cube is 1 and coefficient of s is 9 minus k. So I had written 1 and 9 minus k. The next element is s square, that is even power. So we have to join all the even powers. So here s square and the next element will be s to the power 0. So here coefficient of s square is 5. Here I had written 5 and coefficient of this s to the power 0 is 1. So we didn't mention it here. So here the value of s to the power 0 is k. So here I am writing k. Right. The next step is we have to find s to the power 1. How to find s to the power 1? I have to multiply 5 into 9 minus k into 1 divided by this 5 corner element. Right. So here I had written the steps. When you multiply, 5 nines are 45. 5 into minus k gives minus 5k. And here k into 1 is k. As I am having minus here, that becomes minus k divided by 5. So when you solve this, minus 5k minus k will give you minus 6k. So 45 minus 6k divided by 5. When you divide it by 5, 45 by 5 is 9 and 6 by 5 gives 1.2. Here k. Right. So this is our element of s to the power 1 row. 9 minus 1.2k. Right. And the next step is finding s to the power 0 element. So how to find this element? This term multiplied by k minus 0 into 5 divided by this corner element again. You see here 9 minus 1.2k into k minus 0 divided by 9 minus 1.2k. So here these two elements are same, so they cancel each other, and finally the remaining element will be k here. So k, so this is our s to the power 0 element, right? So here we are asked to find the value of k for which the system will remain stable. So we are going for s to the power 1 row because s to the power 0 has only k, right? So for this thing, whenever you take k, we can say the value of k should be greater than 0. That's it. Because when you consider the first column of Routh array, this is our first column of Routh array. The first two elements are positive, right? So when will be the system stable? When all the elements of the Routh array, that is first column of Routh array, should have the same sign, okay, either plus or minus. So here the first two elements are already having plus sign. So when these two elements are positive, then we can say the system as stable. So we are moving to s to the power 1 row. So here again the value of k should be greater than 0, right? Similarly here this element value should be also greater than 0, right? Am I making the concept clear? So here I am equating 9 minus 1.2k as greater than 0. So I am moving this minus 1.2k to the right hand side. So this minus becomes plus here. So 9 is greater than 1.2k. In other words, we can say that 1.2k is less than 9, right? Both these are same. They mean the same. Then the value of k is, when you move this 1.2 to the right hand side, that becomes the denominator part. So 9 divided by 1.2. So the value of k is less than 7.5. So what it means here, whenever the value of k is less than 7.5, this system will remain stable, right? So the range of k is, whenever the value of k lies between 0 to 7.5, the system will remain stable, right? Hope you people understand the problem well. Thank you.